Hey there, Mr. Weaver here, and this is 8th grade Module 11, Lesson 4, Two-Way Tables. After this lesson, you need to be able to construct and interpret a two-way table using relative frequencies. Let's learn. Construct two-way tables. A two-way table shows data from one sample as it relates to two different categories. One category is represented by rows, and the other is represented by columns. This two-way table here shows the results of a survey about drama and art participation. 146 students were surveyed, and we can see that total down here. It's the total of the totals. So maybe these 146 students were asked, do you participate in art or not? And also, do you participate in drama or not? And then all these things were combined together. So reading this, we might take those survey results and put them in a table like this. In our two-way table, each row shows the frequency of a student's participation in drama. So either we have drama or no drama. Each column shows their participation in art. So either art or no art. In these boxes, it tells you how many fit both categories. So here we can see 26 students have art and have drama. So they participate in both. 14 students are not in art. They're also not in drama. So they are not doing either. We can answer questions using this table, such as how many students participate in drama but not art. To find this, I would say drama is this part right here and not art. So I want that number right there, 38. How many students are participating in art but not drama? Here's my art and not drama. It must be 68. So I'm just looking for where both categories are intersecting. In our two-way tables, we are also given some totals. The last number in each row, that is your totals of the row. So a total of 64 students had drama, regardless of if they participated in art or not. While 82 did not participate in drama, regardless again of if they participated in art. We get these totals by adding across till we get to our total. So 26 plus 38 was 64. 68 plus 14 is 82. In each column, we also have a total. We get these by adding down. So 26 plus 68, there were 94 students in art, regardless of if they were in drama or not. There were 52 students that were not in art. Again, we don't even take into account if they were in drama. We just add them, no arts together. And if you noticed, in this bottom corner here, we said it was the total of the rows and the total of the columns. To get that last number, you can either add your totals or add your totals from art and no art or drama or no drama, add or add. Either way, you should get the number in the corner because that is how many people were surveyed. And a good way to check is when you come up with a number at the end, double check to make sure it's the same going both ways. If it is, you probably have your table filled in correctly. Here we can see how to construct a two-way table that's not completely filled in. A two-way table is made by using the sum of the rows or the columns. Many times you're going to see two-way tables that look like this, where they are partly completed. So here we have a two-way table showing the results of a survey where students were asked if they own a skateboard and if they own a bike. So maybe question 1, do you own a skateboard? Question 2, do you own a bike? We can see 42 students own a bike and owned a skateboard. 21 students, no skateboard and no bike. There were 89 total people who owned a bike and 57 total people who own a skateboard. So based on what we're given, we can start to fill in some missing information. Here we can see 89 total people own a bike. If 42 of them also own a skateboard, how many of them do not own a skateboard? We can just figure out what do we have to add to get to 89, or subtract to go backwards. So if we're filling in that box there, 89 minus 42 is 47. So 47 people own a bike, but do not own a skateboard. Next, 57 total own a skateboard. Based on this, we say 42 also own a bike. We can fill in this box here because we can just add the top plus the next row to get the bottom. So figuring out what's missing, 57 minus 42, 15 people must own a skateboard, but not a bike. Now we can fill in our last two boxes. So let's fill in this bottom one here. 47 did not own a skateboard here. 21 did not own a skateboard there. So let's combine those two together. 68 total people do not own a skateboard. For our no bike row, we can see 15 people here have no bike. 21 more people have no bike. So adding those together, 15 and 21, 36 people do not own a bike. Now our table is filled in and we have all of our missing information, which is the first thing we're going to need to do because likely after that you're going to need to answer some questions. One quick thing to double check, whichever box you fill in last, you should make sure it works in all the directions. And we never checked this 125. Let's see, does 57 plus 68 equal 125? Yes, it does. Does 89 plus 36 equal 125? Yes, it does. So I added in both directions here to get this final total. It was the same both times. I can be confident that I filled in the table correctly. If I don't get the same thing in both directions, something somewhere is wrong. Example 1. Construct two-way tables. Felipe surveyed students at his school. He found that 78 students own a cell phone and 57 of those students own a tablet. There are 70 students that own a tablet. 9 students do not own either device. Construct a two-way table summarizing the data. So first, let's create a table using the two categories and the given values. They already put our information here, but just in case, let's look at where this information comes from. So 78 students own a cell phone. So here's a cell phone. That's talking about the total. So 78 total kids own a cell phone. Of those 78, 57 own a cell phone and a tablet. So I would put it where those two things cross. There were 70 that own a tablet. There's no reference to cell phones there, so that must be talking about our total. And 9 do not own either. No cell phone, no tablet, so there's our 9. Now we can do the same process that we did in the learn, figuring out how to fill in missing things. So let's fill in this top one. 57 plus what gives you 78. Subtract, we would find that it's 21. Now let's figure out the no cell phone for the tablet. 57 plus what is 70. If I subtract, that's 13. So this box must be 13. Next, we can find our total. So we can do either this one here or this one here. Let's do going down first. So add those two together. 21 plus 9 is 30. So that box must be 30. Now let's add across to find that one. So 13 plus 9 is 22. So that box must be 22. Last, we need to find our total, which is the number of students that are surveyed. So we can either find this by adding going down or adding going left and right. Either way, 70 plus 30 gives us 100. Let's double check by going the other direction. Add 2, I get 80. 80 plus 20 is 100. So no matter which direction I got, it's 100 both ways. I can be sure that I filled this in correctly since my last box I checked both directions and got the same answer. Check your understanding, read through the situation, and complete the two-way table. Pause the video now and complete the check. Let's check. So first, let's fill in some things that it tells us. So she surveyed the students and found 38 males agree. So males that agree would go here, 38. There are 70 that do not. So still talking about males, but they must disagree. 70 do not. There were 92 females surveyed. We don't know if they agreed or disagreed, so that must be talking about our total. And 41 of the females agree. So 41 females agree. Once we have that in, we can fill in really any box as long as we know enough information to get the missing box. So I'm going to add these two together first and come up with my total. So 38 plus 70 is 108. Next, I'm going to just add down 38 plus 41 is going to equal 79. We can fill in this missing box here. If I have 41, what do I need to add to get to 92? That must be 51. 41 plus 51 is 92. Almost finished. Let's add going down. 70 plus 51 is 121. Finally, for our total, let's add either direction and then check going the opposite. So 108 plus 92 is 200. Do I get 200 if I add 79 plus 121? Yes, I do. So I can be sure, since I got the same thing in both directions when I was finished, 200 must be how many people were surveyed, and I can be confident that this is filled in correctly. Let's learn. Find and interpret relative frequencies in two-way tables. In the last two-way tables that we've seen, our boxes showed the frequency, or how many times each thing showed up. Sometimes a two-way table can show ratios, or what are called relative frequencies, for the rows or for the columns rather than the actual values. Relative frequency is just the value of the subtotal compared to the value of the total. So when we're talking about relative frequencies, usually we're referencing one of the totals but not the other. And in fact, when you see some of the examples, you're going to notice that we fill in one of the totals but not the other. As we're going through this, we could write relative frequencies as fractions, decimals, or percents, but here we're going to go with decimals. So that way we can quickly turn them into percents if we need to. Here we can see our two-way table with the different types of relative frequencies. First, we could look at relative frequencies by column. So notice my column is all filled in. My rows are not. That's how you can tell you're doing it by column. If we're sorted by column, my total for my column is on the bottom, while my number for the top is what is in that box. So this is 250 people out of a total of 295. This is 45 people out of 295. 30 out of 145. So by column, it's the number in the box out of the total for that column. Rows are going to work the same way. Notice the row is full. My columns are not completed. Again, to find my relative frequency for the row, I'm going to take my subtotal from the box divided by my total for the row. So here, 250 out of 365. Here, 115 was in the box out of 365 for a total. What do these things mean? Well, we can use our relative frequencies to interpret the data. Here they're written as decimals, but we could easily turn each of these into a percent. So this is 68%, 60%, 32%, 40%, and so on. Our total should always be 100% for our relative frequencies. If we're trying to interpret, say, this number right here, 0.68 or 68%, since we're dealing with our row is honor rolls. So 68% of the people on the honor roll did whatever it says up here. So 68% of the honor roll row played a sport. Or we could say 32% of the honor roll do not play a sport. We could look at the next row and say 60% of the not honor roll people played a sport, or 40% of the not honor roll people do not play a sport. So this number is relating the two things together by a ratio or a decimal or percent. If the row is completed, it's of those people, and then it tells you what they did. Example 2. Find and interpret row relative frequencies. The table shows the results of a survey that asked adults and students at school whether they preferred to use a tablet or a laptop. So here we can see our results. 57 students prefer a tablet, while 21 students prefer a laptop. 9 adults preferred a laptop, etc. 100 people were surveyed. Here's our totals. We need to find the relative frequencies by row. So I don't even care about my column totals. I need to go by row. Are students or adults more likely to prefer laptops? So first, let's find our relative frequencies by row. So let's compare students to the total compared to adults to the total. So 57 students out of 78 used a tablet. So what's 57 divided by 78? That would be 0.73. We're just going to use a calculator to figure this out. Compared to a laptop, 21 preferred a laptop out of the 78, so that would be 0.27. For the adults, 13 preferred a tablet out of the 22 adults, so 59, and 9 out of the 22 preferred a laptop. Again, they filled this in for you for the most part, but if we had to fill this in ourselves, to get this value, first I'm going to start as my ratio. I just took the number that was in the box and divided it by the total. So here I get 57 out of 78, 21 out of 78, 13 out of 22, 9 out of 22. used a calculator to divide it, and I came up with my decimal, rounded to the nearest hundredth. Now that we have our relative frequencies, we can figure out, are students or adults more likely to prefer laptops? The relative frequency for laptops. So if we're looking, we have 0.27 or 27% of students or 41% of adults. Which one is more likely to prefer laptops? 41% is more likely to prefer laptops. That's a higher percentage, or 0.41 is higher than 0.27, so they would be more likely to prefer. If we wanted to know less likely, we would choose the smaller number. Check your understanding. Read through the situation, and first fill in the relative frequencies. Use a calculator to divide and round to the nearest hundredth. Pause the video now and complete this check. Let's check. So first, before I show the decimals, let's make sure we can write our ratios correctly. So we're looking at row relative frequency, since our rows are what are completed. So this one here would be 38 out of 108. So 38 divided by 108, that would come out to be approximately 0.35. 70 out of 108 would come out to be approximately 0.65. 41 out of 92 comes out to be about 0.45, and 51 out of 92 is 0.55. Next, are males or females more likely to disagree with the new rules? Pause the video again and complete this last part of the check, if you have not already. Check your answer. You should have said males were more likely to disagree with the rules. Because if we look at the table, 0.65, so 65% of males disagreed compared to 55% of females. We can see we're looking at our disagree, 65 compared to 55. This is more right here than this one. Example 3. Find and interpret column relative frequencies. The table shows the results of a survey about the number of students that are left-handed or right-handed and whether they prefer music or sports. Find the relative frequencies by column. Is a left-handed or right-handed student more likely to prefer music? So let's first find our relative frequencies by column. So notice my row totals are gone. Just like our row relative frequency, I'm taking my box subtotal and dividing it by my total. So 8 over 15, what they're showing. And that it comes out to approximately be 0.53, 53%. I could do 7 out of 15 and I would get 0.47. Box total divided by total, and I would get 55 out of 135 is 0.41. 80 out of 135, 0.59. So I just did the same thing, but my total is now on the bottom instead of the right. Next, let's determine if a left-handed student or a right-handed student is more likely to prefer music. Explain. So here we're given our relative frequencies that we just found. We're looking for more likely to prefer music. So here we're looking at music. Which one is more likely? That one has a higher percentage. So a left-handed student would be more likely for music than a right-handed student, since 0.53 is greater than 0.41. Check your understanding, read through the situation, complete the relative frequencies by column, then answer the second part. Pause the video now and complete the check. Check your answers. Here are the relative frequencies you should have got. So band 15 out of 48 is about 0.31. 33 out of 48 is 0.69. 29 out of 52, 0.56. And 23 out of 52, 0.44. Next, was it more likely that a student enrolled in band or not enrolled in band? Are they more likely to be enrolled in art class? Let's look at our table. So we want art class. We have band, not in band. Which one's more likely? That one has a higher percentage. So a student that's not in band is more likely to be enrolled in art, since 0.56 was greater than 0.31. Before we end this lesson, I want to go back to the original question for example 3 here. We were given the totals for both parts. Now, ignoring that it tells you to solve the relative frequencies by column, what if it didn't tell you which one to figure it out? What if it just asked you this? Is a left-handed or right-handed student more likely to prefer music? How would you know if you're using the row relative frequency or the column relative frequency? So the quick way to figure out if you want column or row, rather than just doing both of them, look at the first part of the question. Is a left-handed or right-handed student? So it's talking about left-handed or right-handed. You're deciding between those two things. Since those are your columns, you need to do a column relative frequency. If it had asked something about, are students in music or students in sports more likely to be left-handed, then the thing would be talking about, are the students in music or sports? That's the part that they're talking about separating. So you would have to decide music or sports and then pick between. So it's really all about that first part. Who are they talking about? Depending on who that subject is, will help you decide if you need columns or rows. In this case, we need columns.